Good morning. My name's John Hauser. I'm a Combat 21 developer out here at TRAC-White Sands, and I've been here for almost 12 years. I started off as a contractor, and then I moved on to being government. So I got my degrees a while back. It took me a while, much longer than probably a fair amount of other people, but I got a bachelor's in math and computer science from Adams State College in Colorado. And then I went up to Colorado State University and got my master's in computer science. So we're going to be talking about task tree. I'm super excited about this project. I've been working on it for a fair amount of time. A bunch of other people have added to it and done more to it than I ever hoped could be possible. So it's really exciting to talk about kind of what the history has been and the process. So we're going to spend a little bit of time talking about scenario integration and some of the issues that have been identified in terms of efficiency with that historically, and then we'll go into the history that led to task tree, and then how it has addressed some of those inefficiency problems, and then we'll talk about some of the things that are planned in the near future for that. So scenario integration. So Augustine yesterday gave a really good overview, detailed overview of integration. He went into and had some demos associated with that. And I'm not going to go into the detail of this. I just want to have a brief overview. I wanted to paint kind of a bigger picture of integration, and just to set the stage a little bit, I wanted to talk about what we do here at TRAC, just a really high level view. So for example, let's say the Army wants to introduce a new tank, and their question is should we introduce tank variation A or tank variation B? And so they'll come to TRAC. TRAC will discuss it amongst themselves. They'll gather a whole bunch of experts together, continue to discuss it, and eventually some additional experts will come and they will create a mission or a scenario. And the idea of that is to help highlight, hopefully through the course of this scenario, they will be able to highlight some of the performance issues of tank A versus tank B. And once that scenario is created, they'll hand that over to a scenario integrator, and their task is to encode or translate that story that's been created. You know, entities move up a route, they split off, this platoon goes over and does this thing, this platoon continues up the route, so on and so forth, a whole bunch of information, a whole bunch of detail. They'll take that information and they'll try to encode it within our model. That model will then be run. They'll take the information associated with all the data, all the performance issues, all the damage information. They'll take that tank A information, put it in the model, run that model a bunch of times, get a bunch of numbers from it, crunch and process those numbers, and then they'll swap that tank A out with tank B, do that process again, run the model, crunch the numbers, do some post-processing on it, and then they'll package this whole thing into a presentation, and they'll say, this is how tank A performed, this is the expected cost of it, this is the expected timeline of how long it's going to take, this is the performance of tank B, this is how long it's going to take, this is how much it's going to cost. They'll package all that together with a paper, give it over to the people that originally had that question, the decision makers. They'll say thank you, and then the Army will have another question, come to TRAC, and that whole process will go over again. And so what I'm interested in, and the thing that launched task tree in the first place, was that scenario integration piece, that process of taking that story that's been established and constructed and translating it or encoding it into Combat 21 so we can actually get some useful information out of it. And during the process before kind of when this thing started, spent a bunch of time interviewing integrators to ask them essentially, so what's what's the thing that's taking the longest in your job? If you had an easy button at any point that could take care of some situation, what would that do? What is annoying about using any of the tools? And spent this long time interviewing anybody that we could. And out of that came some inefficiencies that needed to be addressed. And probably one of the biggest ones is that it just takes a lot of time to make a scenario. And part of that is just the testing process. That if you have a scenario that takes maybe 20 minutes, 30 minutes, 40 minutes to execute within the model, and your task has been to work on a piece of the scenario that's towards the end of that, in order for you to test it, you have to wait those 20 or 30, 40 minutes for the model to do its thing before you can even test to see if your little piece has been working. And if there's a bug and you don't really catch it and you don't figure out what the bug is right at that moment, then you have to start the process all over again. You have to close it, you have to start running the model and wait those 20, 30, 40 minutes. And it's just this slow, cumbersome process. Another is coordinating events. So scenarios have all sorts of little intricate pieces associated with them. Sometimes you want to do things at the same time. You want, while you're going up this route, you want this other group to be clearing out this building. Sometimes you want them to happen after each other. After these vehicles go up the route, you want to go and do this. Sometimes you want a delay in between those, and there's all these different situations. It's complicated to set that up, and then if at some point the storyline changes, it comes from the decision makers. They say, actually, we'd really like to have this kind of story in there. That's even more work, and that kind of thing happens all the time. Complex behaviors. So there's complex behaviors that are written for a particular study, but there wasn't really a central place that you could go to find what you were looking for. You may have had this inkling in the back of your head of, oh, didn't we use some kind of behavior, which is essentially the little kind of coded brain that different characters have in the model that respond to different events, that follow instruction. Those behaviors weren't in a central spot that you could easily access them while you were building this story. Essentially, behaviors can almost be thought of as small little elements of a story. So if a story was like a paragraph or a chapter, these would be words or sentences within that story that could be built. And this is probably one of the biggest things, this next one. Useful tools may not necessarily be used tools. And this is probably one of the biggest lessons that I've learned out of this whole process is there are many developers and there are many integrators, and sometimes specific tools are created to address a certain issue. But sometimes integrators come and go. Sometimes they leave the organization and new ones will come in. And in that process, a tool that maybe specifically was designed to solve a certain problem goes unnoticed and unknown. And there's the old adage of a mediocre tool that is actually used, is infinitely better than a great tool that's never used. And so the whole idea of if you build it, they will come has not been my experience. And so it's important that if a tool is made, that it goes through all of the necessary iterations and almost marketing and sales and pitches to get it to be used to be actually useful and make a difference. So that investigation led to TASTRI. So about 3.5 years ago, we were at a workforce address, and the director kind of made this statement, not in so many words, but essentially said, so those that make Combat 21 scenarios, you're doing a great job. Could you do it 20 times faster? And I was finishing up one of my projects at the time, and I thought, yes, I got it. So I went and I emailed my boss, Christine Powell, and I said, can I work on this? And her response was, yes, go forth and do great things. And she recommended getting in contact with David Haker, who is the CITS lead. And CITS is the scenario integration tool suite, which is like our main integration product that we use to make scenarios. And so that was a natural fit there. And so we just started interviewing. And so we got everybody that we could, asking them those questions about efficiency and what's annoying. And out of that came that list from the previous slide, those list of inefficiencies. And this year is, 3.5 years later, this is what we have so far. Just a quick overview of what we got going on. Task tree is a collection of essentially modified behavior trees. Behavior trees are an idea that's been around since like the 70s as far as organizing different events. This little window here, if you can see the screen, in the upper left-hand corner is a collection of different trees that are used in this particular scenario. You click on one of those, it populates this lower right-hand section to display the actual tree that has all the different events in an organized way. And then you click on one of these individual nodes, these rectangles here, that have a collection of different properties. This in the upper right section is a little window that has it's kind of a memory management system that allows different trees to share information. And the motivation for a behavior tree style of interface was from the gaming industry. So a couple of years ago, Breath of the Wild, which was a really popular game on the Nintendo Switch gaming system, came out. And not only did it have its primary story, but it had 76 submissions associated with that story that you could play at your convenience. And they only spend a couple of years typically on these games. And obviously they have like tens of millions or hundreds of millions of dollars to generate these things. But 76 sub-games that all are unique, that all have different characters, that all have different interactions, that have different subplots, different prizes at the end, rewards that you get if you complete those missions. That's a huge accomplishment. And so at the very least, man, asking the question, how on earth do you guys do all that? Given the fact that from our point of view, the scenario integration process, that encoding, you have something in your mind, you have some story, something written on paper, something in a spreadsheet that you're trying to translate into a model. How on earth do you do that? And after some investigation, one way that different models do that, they use a behavior tree, and it's a modified, it's a hybrid, it's a hybrid model. It's changed since the 70s, obviously, but we looked specifically at OpSiv, which is the Unity, which is a tool that you can use to make games using the Unity engine, and then we also looked at Unreal, and both of those use a behavior tree style. And so how we took that information to craft task tree was getting inspiration from that, and wanted to take on a user-first approach, especially from that lesson of making sure that it's not just a useful thing, it's not just some tool that's just going to hang out on the shelf, but that if a difference wanted to be made, all the extra work associated with making it a used tool had to become a priority. And so taking a user first, sometimes as a developer, we get a request to do something, and let's say it's a new button that does something. So we work on it, we get the button, we say, all right, button's done, and then the user that requested it will use it for that time, but it may be lost in the shuffle. And so there isn't the, I'm going to make this a standard mindset. So want to make sure that this is useful, that it's used, that any documentation that we make is actually beneficial, that it's easy, that it's searchable, that you can find what you're looking for, whether it be some complicated behavior or it be some documentation associated with something. And making sure that I'm not just a developer on this, I'm a user. And so I am super annoyed by inefficient software. And so at the very, very, very least, it has to pass my level of standards. And then approaching each of the different users and then seeing if this is acceptable, if it's being used, if it's good. And it's not just a one-time thing. It's a repeated over and over and over process to guarantee that. We have a bunch of different types of nodes that you can use for a tree to kind of capture the complexity of these different stories. Abstraction, and I'll get into those nodes a little bit later. Abstraction is a huge part of that makes this whole process work. Abstraction is kind of the idea of you want to hide the information that isn't necessary to understand using it. So for example, a car. You don't have to worry about how a combustion engine works, all the gears flying around inside of a transmission, or a braking system, or how a CD player works, or a radio, or anything in order to operate a car. All you got to do, open the door, sit in, turn the key. It's going to take some skill, it's going to take some experience, but you have gas, you have brake, you have steering wheel. Maybe you have some kind of a gear shifter. You don't have to worry about all the other stuff. And the idea of abstraction is you want to have a complex behavior that can do this specific thing. It's pretty easy to understand, and you want to hide as much as you can so that it's easy for you, but also the hope is that you have confidence in that thing that you're doing, that it does what it's supposed to do. And if everything goes well, then you don't have to worry about it, and it's significantly simpler, and you can create things much, much faster. We have a searchable behaviors library that's slowly building. We probably have about 100 behaviors right now, and they are Python. So the system is standalone. We'll have a collection of Python behaviors that are read by the system, so that if you have a Python script that's in the correct format, when you open up Task Tree, they will be represented as little nodes. This little Python action here, this blue one that you see, that'll be available. All the documentation's there. And then this is an exciting thing, the debugger tool. So this is the thing I'm going to get into next. So the debugger basically allows you to, during the course of execution of a given tree, you can see what all the different nodes are doing. I'm going to show you a video in just a little bit. And what it allows you to do is that if there is some issue, if there is some bug that you're having, that you've identified, you can pause the debugger, or you can have it stop when it reaches some particular node, and you can investigate anything you want to, any of the states, any of the little bits of data, to understand more of what's going on. And in this next video, you're going to see a tree with several different branches that have a bunch of flashing going on. And basically all that is that the different nodes are being reset based on the complexity of the scenario that you're seeing. And the border of each of those nodes represents the state that that node is in. So if it's green, it means that it's finished successfully. Yellow means that it's right in the middle of executing, that it's running right now. If it's red, it means it finished, but with failure. If it's black, it's not started yet. And blue means that it's paused for right now. It'll be restarted like in a little bit. And so let me go to the next slide. This window in the lower right hand is what's going on inside the model. So the model is like a 3D representation of a model, but typically how the user sees the model is just an aerial bird's eye view map, 2D map. And it has a collection of entities on it. And in this particular case, the scenario is has an entity in the center that's observing different red bad guys around it. It's observing, it's sending radio communications, it's firing at different times. There's a lot of stuff going on, but it's cycling through different targets and then communicating and then engaging on each of those. And so you're going to see a lot of flashing that's going on in the background. This window here represents the tree that is currently being executed. At the moment, there are some nodes that have green around them. There's one here that has yellow around it, means that it's currently being executed. And there's several that don't have much of a border at all, and that means that it hasn't been executed yet. So let me go ahead and play this. So different things are flashing. There's a helicopter, if you can kind of see that in the center right here, that's changing orientation and firing. This guy just got exploded. And what this debugger allows is that at any point you can pause and you can click on any of these nodes and find out what their state is and what they're doing. And it allows you to very quickly discover what the problem is and what needs to happen in order to fix it. So path forward. We're going to continue moving towards that 20 times faster goal, always looking for additional techniques that we can go beyond that. The ultimate goal that I've had for a while is, I mentioned earlier that there are experts that get together over the course of 2, 3, 4, 5 days that create that story. My eventual goal is to be able to create the entire scenario, the entire Comet 21 scenario, during the course of that scenario creation process. Just because all the experts are there, they would have a bunch of questions. If they could see it being made and clarify some of their ideas in real time up on a large screen, that would make the story that they're trying to convey, that would highlight the differences in these the different alternatives that much better. And to add to that, there are a set of tools called the map extension tools that's going to provide a simple, almost pre-processing model that will assist in the creation of that. And basically what that is that the model takes a long time to run. It has a lot of calculations, a lot of physics that it's doing. If we can make a simple model that can run through the higher level stuff very quickly, and especially if you can go to a particular spot in the scenario and jump to that particular spot, that will make this whole process significantly easier. Again, we want to make it used. That's probably one of the biggest things, is that even if at the moment it's not as great as it could be, going through the extra work to make sure that this is used so that it actually makes a difference is high on the priority list, which involves training and a lot of interaction and constantly having a critical eye on every part of this process to find any hiccups along the way, but ultimately to actually get this used as a standard and make a huge, hopefully huge difference. That's it. Is there any questions?
Yeah, I have a question. So I got here a little bit late. I apologize, but that was basically a Java graphic coding system using some Python inputs, if I'm not mistaken.
Right. Yep.
Okay. Okay. Thank you.
Any other questions?
I don't see any questions, John, but that was so interesting. That methodology that you guys are employing there. I see somebody clapping. I really enjoyed that. Great job.
Oh, yeah, thank you.
You're quite welcome.
Sorry, it does look like Juan Avila has a question. Go ahead, Juan.
I guess I do have a question for you, John. What do you think is the next step, or what do you see happening next, or what do you expect to do when it comes to this project? Over.
Yeah, so for my piece at the moment, I've just been working on the GUI, and so there's one piece that I'm currently in the process of working on, basically just to be able to very quickly add kind of the desired elements that you want to for a particular behavior. So we're trying to make really generic behaviors that aren't like specific to some process that would only be used for one specific scenario. We're really trying to make them generic. And so in order to make them generic, it means that it has a bunch of inputs that it needs. So like instead of having a specific behavior that has these specific vehicles going up this route on this specific route, there would be a slot for what vehicles do you want to move and what on what route. And so like, for example, like those two things, and maybe like a speed and stuff. There's more detail than that, but making those generic behaviors the piece to allow and pick which vehicles in a very quick manner. That's the piece that I'm working on now. When that's done, and this is just for me. Other people are working on different parts, but when that's done for me, I'm going to go back and begin to review and test and refine several of the behaviors that already have been created, and then just basically pretend that I'm a beginner user, and I'm going to go through the whole process and just, with a notepad, just write down everything that I find along the way that's, for me, annoying. And then we're going to start doing a bunch more documentation, not just like to say that we have documentation, but to actually involve the integrators with creating our own like tutorials, and hopefully use some video, and want to get some animated GIFs inside of our documentation, so that if a behavior is pretty complicated, that instead of just being able to read what the behavior does, you'll be able to see like a little video of what the behavior does. Just anything that we can think of that allows the user, once they're really familiar with the system, to very quickly create this scenario, to identify all those little pieces of the story.
Thanks, John.
Yeah, thanks, Juan. That was a great question.
We're still open for questions. If anybody has another one for John before we go on break. Okay, I don't see anybody's hand raised, so let's go ahead and take a 15-minute break. I want to remind everybody that we have our parallel sessions coming up at 10:30 in this meeting room. We're going to present Data Analysis Professional Development Opportunities by Lieutenant Colonel Collins. And in the parallel session meeting, we're going to have Multi-Agent UAV System Analysis by Major Fletcher from TRAC Monterey. I'll go ahead and throw up our intermission slide and see you back at 10:30. Thank you. John, great presentation.
Yeah, thank you.
There we are, view, full mode.